Activity 4. If you've chosen to do this activity and are a little struggle getting started, I want you to remember you may use your notes, but also, let's read through. I'm going to go through like one in each example so you know what to do. So for examples, exercises 1 and 2, choose the number that is written in scientific notation. If you remember, to be in scientific notation, the decimal has to be behind the first number that's not a 0, and we read left to right. So when I say behind, I mean it needs to be on this side of the number. So what I want you to do is just look at these 3 examples for number 1. We have 12.3 times 10 to the 4th, 1.23 times 10 to the 5th, or 123 thousandths times 10 to the 6th. Which one of these would be in scientific notation? Is it the first one? Is our decimal in the right spot? Is it behind the first number we came to that's not a 0? Hopefully you're thinking, no, it's not. That would have to be right there. So this cannot be our correct answer. So we go to the next one. Is the decimal in the right spot? It is. We have a multiplication symbol, and we have 10 to some power. So I'm thinking that's the right answer, but let's check. Over here, we have 0.123. Uh-oh. Is the decimal behind the first number that's not a 0? Well, it's behind the 0. It should be behind the 1. So technically, even though this looks like scientific notation, it is not. So you would need to circle which one is in scientific notation. You're going to do the same thing for number 2. Now in exercises 3 through 6, find in. Basically what you're doing is ignore this, take these large standard numbers and put them in scientific notation. If you can do it on this paper, great. If you need a separate sheet, that's fine as well. So we do our rule. We put the decimal behind the first number that we come to when we read left to right that's not a 0, and then we count how many spots we had to move it. 1, 2, 3, 4, 5, 6, 7. So if we look over here, they told us 7.2 already. We've got it. Times 10. Well, what would my exponent have to be if I move this 7 times? It would have to be a positive 7. So n was just asking what our exponent was. So you may do the next 3 now. For exercises 7 through 12, you're just writing the number out in standard form. You're getting rid of, you're putting it back into a regular form like this up here, where you'll have to write 4.9 and decide which way to move the decimal. Remember, positives, think of your number line. If 0's in the middle, positives are to the right, negatives to the left. So if you have a positive exponent, you move to the right. If you have a negative, you move to the left. In exercises 13 through 18, you're taking it out of standard notation and putting it back up here like this, in scientific. Whenever something says scientific notation, you have to put it with the times 10 to the power. So in scientific notation. And now these last ones, be very careful. A lot of people that have done this so far have made mistakes. On these last 4, they are not in. I know they look like scientific notation, but if you think of our rules from up in the first 2 questions, to be in scientific notation, our number would have to be, our decimal, would have to be behind the first number that's not a 0. So if we had to move this one more time this direction, it wouldn't be a positive 3, it would be a positive, so it would be 1.66 times 10 to the positive 4. That is the correct way to write it in scientific notation. So for each one of these, you need to put it into the correct form, because if you look, the decimal's not in the right spot. The decimal's not in the right spot. Uh-oh, there's no decimal at all we need to put. So you need to decide how to put this in scientific notation.